Cool. So hey everyone, my name is Advait. I run the engineering team at GoGuardian. We build analytics software and monitoring software for Chromebooks, primarily for schools. Yeah, I'm here to talk about StatsD. So just show of hands real quick. How many of you guys use StatsD in production right now? So how many of you guys, like my team right here is raising their hand. How many of you guys have like some sort of monitoring set up for like your services and things like that? Okay, cool. So for the rest of you, this is going to be awesome. So what is StatsD? Basically, the guys at Etsy in 2011 decided that we need a way for engineers to be able to track application-specific metrics. And the idea was like, back in old days thinking, when engineers develop like an application, they package up an application binary and they like kick it over the wall to the ops guys. And the ops guys go and run it, and then it's the ops guys' problem. And obviously, as many of you guys know, that trend is gone. And nowadays, you don't even have ops guys anymore. For example, all of the engineers that push code at GoGuardian, they run the services. And so how did ops guys make sure things were up? You kind of have, as an ops person, very like, I don't know, not fine-grained metrics about what your applications are doing. You have CPU utilization, network I/O, things like that. But you're really unable to crack into like the app binaries to like figure out what's going on. Like, why are my requests taking so long? And so the guys at Etsy decided, hey, we need a way where developers who actually understand the internals of the application to outfit their application with metrics. We need a dashboard so that we can kind of view these metrics and figure out what's broken, why it's broken, in a level that's much more meaningful than just CPU utilization and network I/O. So StatsD consists of really 4 pieces. You have the API client. So that's going to integrate with your actual application. And the original StatsD implementation was just in Node. Since then, StatsD has really grown in popularity, and there's API clients for literally every application backend. So Ruby, Python, Java, Scala, anything. You'll get a StatsD client for it. But one of the guiding principles of the StatsD implementation was really just simplicity. They didn't want to reinvent the wheel. They didn't want to create this like huge monitoring framework, and so they decided to make it really simple. So you have a UDP protocol, which your API client just wraps. And then on top of that, you've got this daemon, which runs typically on your actual application servers. So you outfit your application with metrics, which will send UDP packets to a local daemon. The local daemon will kind of aggregate these packets together. This is probably more meaningful. And send them up in batch, so to a backend. And they kind of kept StatsD, like the implementation, as the very left-hand side of this picture, and left the backend as its own thing. Like, people have created graphing libraries, people have created metric aggregation libraries. So again, don't reinvent the wheel. So a common question that people have when they look at StatsD is they're like, why UDP? That doesn't make any sense. And I think it's a great question. And the primary reason is that you don't want your metrics to impact your application in terms of performance. Like, you don't want to spend 20% of your cycles collecting metrics data, processing metrics data. You want this to be as lightweight as possible. So UDP is kind of send and forget. And although it doesn't guarantee delivery, when you're running on localhost, there really isn't too much of a problem. So it's great. So let's talk about backends. In the 2 slides ago, you basically have the right-hand side over here. So the original implementation started off with Graphite. And Graphite is a really common sort of graphing implementation, metrics collection, things like that. And then there's also quite a few more nowadays, like actual backends for StatsD. The one I'm going to focus on today is Datadog. Datadog is proprietary, and we really rely on it internally, and it's the greatest thing ever, so I'm going to talk about it. But I know a lot of you guys love open source, and so Graphite and Ganglia, and there's several other more open source ones, which will be able to do all the metrics collection you want for free. There's also more backends available. If you want to take raw metrics and pipe them into a database and do your own sort of aggregation and cool stuff on top, you can do that. There's quite a few more. This is just like the big three that I thought of. So yeah, let's talk about actual implementation. Again, guiding principle of StatsD is simplicity. So with 2 lines of code, you've got a StatsD client, which is, so I'm going to talk about JavaScript here, obviously. But again, this is really client agnostic. There's similar idioms in literally every other language out there. So you get a handle on the StatsD object. You tell it to connect to localhost on the UDP port 8125. And then you're up and running. You're able to collect metrics. So let's talk about those. So StatsD metrics. There's basically a few primitives that you can use, and you build like your bigger kind of like the things that you want to collect out of these like really small primitive metric types. So the first metric type is a counter, and if you want to count something, a counter is a good thing to use. And and so we use it to track, for example, page views, failed authentication, database requests. Just put a counter on it, and there's basically many different ways where you can actually influence a counter. But you have standard increment and decrement operations, and then you have a count operation. And so one thing I want to talk about here are these strings. So StatsD kind of requires you to associate a string with the metric that you're collecting. And there's all sorts of conventions for how you should do that, but we basically use periods to delimitate sort of namespacing. And that's like the common industry convention. So before this, typically before auth.failure, you would typically prefix that with the application that's actually running the code. Maybe even add on like the environment, whether it's staging or production or whatever. But yeah, you get a string, and that's your counter, and you can increment it, decrement it, and this is what you get out of it. So a couple days ago, we actually launched a production service, and we did it in an interesting rollout. We did it kind of in a phased way. We had direct control over how quickly we could send traffic to it, or what percentage of our total traffic went through this new service. And it was really, really important to me that this service did not go down, because it was really mission critical, and we did all of our load testing and due diligence behind it. But we wanted to make sure it was functional. So we outfitted literally, like we went crazy with monitoring. So almost every aspect of it is outfitted with metrics. And this is a simple panther.request. Panther is the name of the service. So panther.request, just increment that every time a request comes in. So I can't go over there and point, but you can kind of see the ramp up as we turn the knob all the way to 100. We reached a peak at about 97 requests per second. And that's the typical end of our really cyclic workload. So we were able to see live, as traffic was coming in, a nice simple graph explaining what's going on. So it's so comforting when you can see this, as opposed to just CPU utilization. It's just like, wow, I'm like actually understanding what's going on. So that's counters. Let's talk about tags. So tags are a Datadog specific thing. They're not really available in Graphite, but you can really fake it. But I want to talk about them because they've really changed how we do monitoring. And the concept of a tag is you have 2 dimensions really with StatsD. You've got the string metric types that you're collecting, and then you've got time. And the goal is to figure out how your metrics change over time. And tags add another dimension on top of that. For example, you could, when you send a metric, you could tag it with the host name, or you could tag it with the Amazon OpsWorks stack that's running on, or you could tag it with production versus staging. And then you can both filter what sort of tags you want to see, But then you can also do cool stuff like this. And so we've got, we're running on Amazon, and we've got basically a bunch of PHP application servers, and we've got them set up with auto scaling. And this graph is kind of throughout the workday how our load increases over time. And every slice is basically a new application server coming in and being added to the load balancing pool. So you can see how many requests per second each individual slice is taking and kind of see how it piles up. And the way we've done this is we basically tag every metric with the host name. And again, if you guys have any questions, please stop me. Just raise your hand. I'm happy to answer anything. So we could build cool lasagna graphs like this, and it's great. And then yeah, this is like really visual too, right? You can kind of see if a particular server is unable to serve the number of requests per second that you're expecting, or see any sort of anomalies. Tags kind of enable that. So cool. Next primitive. Yes.
Can you set globally the prefixes in the tags?
Yeah, absolutely. So, oh yeah. So the question was, can you set the global prefixes for your tags? And yeah, it really depends on the client library that you're using. It's really simple, right? Just prefixing a string. So check your client library. But yeah, we absolutely recommend prefixing with your app name, because your dashboard is going to contain eventually, hopefully, thousands and thousands of metrics. You want to be able to drill down by app and things like that. But yeah, great question. Was that a question right there? Okay, cool. Gauges. So gauges are the next metric primitive. And the idea of a gauge is to measure the value of something at a particular time. So the canonical example for gauges is measuring the fuel in a car tank, or yeah, fuel in a gas tank. We use them particularly to keep track of how many connections we're using in a database connection pool. This is a really useful metric because when services are being stressed, connection pool usage is kind of a really good indicator of latency and when things are going to explode. So yeah, connection pool usage. And you can see with one line of code, basically any time a connection is grabbed from the pool or released back into the pool, you get this graph. And this graph, I'll explain it a little bit, but every bar here is a 5-minute sample. And the y-axis represents the average number of connections that were held open in that 5-minute slot. So as you can see, we're doing really well. We're barely touching database connections. And this was like the same time for that same Panther service. So when there's an outage or something serious going on, you'll see these bars grow huge, like typically up until like the limit of your connection pool. And you'll know what's going on. So again, this is compare this information to CPU utilization. Like you just understand so much more about what's going on. Yeah.
Would you report that on like connection open and disconnect, or would you report that on like an interval?
Yeah, the question was, would you report that on connection open or connect, or would you report that on an interval? And it really depends what you want to do, but we do it on whenever you grab something and whenever you release it back into the pool. I'll get to sampling and overhead in a second, but yeah, that's what I would recommend. Histograms. So this is the next one. This is really my favorite one. The gist of a histogram is that you have a distribution of values that you want to be able to measure. And the most common distribution of values that you typically do measure is request latency. So I send an upstream request. How long is it taking me on average to return? Or I have a downstream request like that I have to process. How quickly am I getting stuff out the door? So the way to do that is basically here we've got a request that we're sending to an upstream authentication server. And before we send the request, we have a start time. And then after the request is complete, we get a diff of the amount of time that has elapsed and say StatsD.histogram auth.latency milliseconds and just pass in the latency. And the cool part about StatsD is that it'll automatically keep track of the mean, median, min, max, and 95th percentile. And when you're tracking latency values or any sort of distribution of values, it's not sufficient to really just keep track of the average. You really have to keep track of the 95th or even the 99th percentile, because it's kind of like a deceiving statistic, reporting just the average. So here we've got the 95th and the median percentile in blue of latency. And as you can see, we're doing quite well, clocking in at about 9 milliseconds for the median. And this is going to be as reported by the application. So it doesn't know like the actual internet latencies. So only for application-specific processing. But I mean, that's pretty solid in my mind. And again, the coolest part about this is that when there's an outage going on, you're looking for information about what's really happening, right? And this kind of really puts it in your face, like, okay, my database latency for this specific database is going through the roof, or my database connection pool is like being maxed out for this service, and then you can respond to that, and it's just so much more intelligent than sort of like blind metrics. Cool. Any questions so far? Sweet. So next primitive, you've got sets, and sets just keep track of unique values. And so here I'm passing in the logged in user's ID, and the idea is show me the number of logged in users that are there. This is what that generates, just a bunch of bars where every 5-minute interval we get basically we get the number of unique values, the number of unique user IDs that were there. And unfortunately, there's like no magic behind this. All that's going on is your StatsD daemon is going to aggregate every sort of unique value for a specific time bucket, and then it's going to send up the aggregate information up. It's not really going to send up every single unique user ID up to a backend. So you're not going to get like magical analytics. But again, this is like valuable information, and it's better than nothing. So sampling. So the Heisenberg uncertainty principle says that you can't outfit an application with metrics without affecting it. Sample, like, it's true, right? Like you're doing some work to collect these metrics, and in an ideal world, it would be zero work. But in reality, it's not. And so this is really where sampling comes in. You could implement something like this. For example, if the number of requests that you're processing is just through the roof, you're spending a lot of time sending these UDP packets. And it is kind of lightweight, and that is the guiding principle behind it, but it is non-zero. And because you don't care about 7, 8 significant figures of information, you're kind of just looking for a rough idea of what's going on. You could use sampling to kind of ease the burden. So the idea behind it is you basically just probabilistically send up StatsD metrics. And if you ever, so in this case, we've got a sampling rate of 10%. If math.random is less than 10%, essentially, we then issue the count. But the thing is, like, because it'll only enter the if statement 10% of the time, you've got to ramp up the actual value that you're incrementing. So this is kind of a burden to think about, and you shouldn't do it this way. So instead, they've kind of put it in the library. Most StatsD clients have the ability to sample, so you just pass in the sampling rate, and then you forget about it, and it'll just probabilistically do everything underneath the covers, including scale up. So it's just fantastic. Cool. Events. Events are, sorry, another Datadog thing. I don't have a logo on there, but they are. These are really cool because you basically have all these graphs, but you really have, as an engineer that's deploying things, kind of really important things that happen throughout the day that can significantly impact your application. For example, deploys, auto-scaling events, just things that happen that you do that affect the system. And you kind of want to see what happened at this time to cause this huge spike in traffic. And so here we've got an example of we did a deploy to our service, which caused the request per second to go to 0. And the width of that gap right there makes me really sad, and we're going to do a lot to shorten it. But luckily, our clients are outfitted with back off. So as you can see, as soon as the application went back up, we have this huge spike, and it eventually comes back down to normal. Don't deploy your applications like this. Use a load balancer. Take instances out of the pool before you deploy. But the point is, like, we did something, and the graph changed, and we could see those things together. And when things are breaking, you have no idea how important and like important this is. So yeah, Datadog. Sorry, I'm not even a Datadog employee. It's awesome. You guys should check it out. It sounds like it though. So they've got a bunch of integrations, and StatsD obviously isn't the only way to monitor your stuff. And you've got all these other things that you're using, like event streams, for example, like GitHub deployments or GitHub issues that are opened, or New Relic for monitoring, Chef for configuring. And then you've got other services too, like MySQL and Cassandra and Solar and all these things that are just up and running that have their own sort of metric systems. Datadog makes it really easy to consolidate all this heterogeneous community of like metrics and stuff into one sort of dashboard. So we did a test run a couple of months ago with Cassandra, and basically Datadog managed to pull JMX metrics. JMX is Java's standard way of outfitting your application with monitoring. So it definitely predates StatsD and stuff like that. So there's a lot of momentum behind it, and the metrics that it produces are great. But it's Java specific. So Datadog will integrate with that. So you can see here we have, I think it's a graph of Cassandra write latency, and we were also doing a MySQL read. So the MySQL read is going to be in dark blue. The Cassandra write is going to be in purple, and then the application time is going to be in light blue. And the Cassandra latency was basically pulled from JMX. And then the MySQL read latency, on the other hand, was pulled from StatsD. And you can see all these metrics coming in and presenting themselves on a single graph. So it's awesome. You should check it out. But yeah, that's it. My name is Advait. If you like graphs, come join us. We're doing some really cool stuff at GoGuardian. And yeah, thank you. Cool, yeah, hit me up.
Can you mix and match the clients in terms of you're recording what's going on in the backend in PHP, and then maybe what's going on in Node in the backend?
Absolutely, yeah.
Front-end JavaScript, which obviously isn't localhost.
Right. So front-end JavaScript is tricky because you've got clients all over the place, and you've got to funnel metrics into a daemon that's running somewhere. I wouldn't recommend doing that. But to answer your PHP plus Node case, yeah, we have a bunch of services, Java, PHP, Node, and they all use StatsD. They all have different clients, but the daemon that we run on the application servers is the same.
So the metrics are all going into the same backend.
Yeah, exactly. So it's great, especially if you have like a service-oriented architecture. You can really correlate how negative stuff in one service affects other services in just one dashboard. It's pretty crucial.
And then was the Datadog choice, do you know if it was specifically because of those things that you mentioned are Datadog specific?
You know, I really didn't want to host my own Graphite server. And I mean, at that time we were really, really small, like 2 or 3 engineers. And it just seemed like a really easy way to get up and running. And since then, it's just been great. Mm-hmm. Yes?
If you're already using something like New Relic that already kind of does all your base level stats,
Sure.
like what are sort of the interesting cases beyond like the base level stats? That
Sure.
you guys are
Yeah, that's a really great question. The question, if you guys didn't hear in the back, is I guess you guys use New Relic, and so how does Datadog, how is it better, or how does it supplement New Relic? Sure. Yeah. So we use New Relic as well. My only gripe with New Relic is that it does a lot of stuff. Like it'll give you like analysis of how you're using SQL and tell you like, what are you doing, man? Add an index here. But it doesn't do everything. Like I want to track latency for a specific call that I'm doing, or I've got this crazy like offline computation that I want to do. Like how long is that taking? And Datadog really allows you to like get to that like fine-tooth comb of like I want to outfit this part with metrics. I think they work really well together, and the Datadog dashboard has the ability to pipe in New Relic information, like all the graphs and all the events and stuff. So yeah, you should definitely check it out. Cool. All right. Thanks, everyone.